we're going to draw an elevation and plan of this block that we have, and then we're going to project an auxiliary elevation. So we basically have just a simple box. Our box is 70 millimeters wide, 30 millimeters high, and then from back to front 40 millimeters. We're going to step in 10 millimeters along the side, and we're going to chop the corner off at 60 degrees. So we have a 60-degree angle here. So that's what I've set up in plan. We have to draw the plan first. The reason we have to draw the plan first is that I don't know what this measurement is here. We weren't given a measurement for that. I have to draw the plan. So the plan, 70 across, down 10, down 40, and then from here I draw my 60-degree angle, and then I can complete the plan. So I've got the full plan drawn in. I'm going to go draw the elevation, but first of all I'm going to go numbering the points on this box. We're not going to number all of them, but I'm going to start off with 1, 2, 3, 4, we'll put 5 here, 6, 7, and 8. And when we're doing auxiliary elevations, the numbering becomes very important. So I've numbered out all the points there. I'm going to put those into my plan view. So my right hand corner here, the front right hand corner, has points 7 and 8 on it. When I look in plan, so I'm looking in plan here. So the front of the object is here. Front right hand corner we said has points 7 and 8. So 7 and 8 are here. That corner there is vertical, so it looks like a dot. The left hand side of that front surface, we've got 5 and 6. Here's the left hand side of that front surface. We have 5 and 6. The slanted surface is number 3 and 4 here. Here's our slanted surface. We've number 3 and 4. And then the back corner has 2 and 1. So back here we have 2 and 1. So make sure you label those points in. I'm going to draw the elevation. The elevation is going to be very easy to draw. It's 30 millimeters high, and the whole top is horizontal. So all I have to do is measure up 30, and I can draw in everything then. I'm going to project up my points from the plan first of all. So I'm bringing up 5 and 6, and then 3, 4, and 1 and 2 are all in the same line. And then I just come along, measure a height of 30, and that'll let me draw in the elevation. So just darken all this in, and we have our finished elevation. So what we're looking at, the front of the object, here's the front surface. Front surface is here in plan, here it is in the elevation. So there's my front surface. My slanted surface, here's the slanted surface in plan, here is the slanted surface in elevation, and then the side, the very left hand side, here it is in plan, and it looks like a line in elevation, so we can't actually see that. That is our elevation and plan complete. I want to label the elevation because we're going to need that for the auxiliary. Now, points 7 and 8, when I brought them straight up, are here. I need to figure out which is which. You'll see point 8 is on the bottom, 7 is on the top. So when I come up, 8 is on the bottom, 7 is on the top. Likewise, 5 is on the bottom, 6 is on the top. When I come up, 5 is on the bottom, 6 is on the top of the elevation. 4 is on the bottom, 3 is on the top. So when I come up, 4 is here, 3 is there. And then right in behind, 1 is on the bottom, 2 is on the top. So again, when I bring up 1, 2, we said 1 is on the bottom, so 1 is actually going to be in the same position as 4. 2 is on the top, so 2 is up here, so it's in the same position as 3. So that point there represents both point 3 and point 2. So that is my labeling finished. Now, where auxiliary elevations come in really handy is they can give us extra information about an object. So I'm going to label this as S, surface S. I want to find the true shape of surface S. So I want to see what does that surface really look like. In other words, what's the real height of it and the real width of it. At the minute, here is surface S, and this is surface S in plan. That doesn't show me what it really looks like, and this is all squashed up, so I can't see what it really looks like. So neither of those views are any good to me, and that's where auxiliary elevation comes in. So what I'm going to do is I'm going to draw an auxiliary elevation to show the true shape of my surface S. To do it, I need to look in at 90 degrees to the surface. So what that means is that at the minute I'm looking down here. Here's my line of sight, looking in from my normal elevation. I'm going to draw a new elevation, and I'm going to draw it out the side here someplace. I need to look in at 90 degrees to this surface. 90 degrees to that surface, and it's only roughly I'm drawing this, is in here. So I need to look in here at that surface. So for me to see what surface S looks like, I need to walk from here. I'm going to walk around, and I'm going to stand and look in here at the object. So to draw it, I'm going to take this out of the way because I don't need it now. The surface S is at an angle of 60 degrees. I need to draw a line at 90 degrees to that, so it's just the opposite, which is a 30 degree angle. So I'm going to project out here at 30 degrees. So I'll just take any point out to begin with. So I'll draw a line out, construction line out, at 30 degrees. I'm going to set up a new XY line. So here's my XY line for the first drawing. I'm going to set up a new one. And again, I'm going to use my 60 degree set square. And I'll draw my XY line here. Doesn't really matter anywhere there at all. I'll draw my XY line. It's a different XY line, so it's called X1, Y1. It's at 90 degrees to the construction line. So I drew the construction line at 30, drew the XY line at 60. Now I'm going to project out the points. So I've got points 1, 2, 3, 4, 5, 6, 7 and 8. So I'm going to take my first points, 1 and 2. So I'll project those out at 30 degrees. Back to my drawing. Height of 1 was 0. It's on the XY line. Height of 2 was 30. The height of it is 30 high. So I can come along and say it now. 1 was on the XY line. Point 2 had a height of 30. So I'm measuring up 30 along the line. So there's point 2. Again, when I come along, point 4 had a height of 0. It was on the bottom. 3 is 30. So I can do the same with all these points. So I bring out my line. So point 4 we said is on the bottom. Here is 4. And number 3 had a height of 30 also. 5 and 6 the same thing. Bring out 5. 5 at a height of 0. Now, instead of me using my drawing, I can use the actual elevation up here because I've got my heights already set up in the elevation. So if I want the height of number 6, what I can do is just copy it. Here's the height from the XY line up to point 6. I can take the same one out. So I follow out my point 6, and so from my XY line I measure up. That is the height of 6. Last two then is 7 and 8. And again I bring it out to 30 degree set square. Height of 8 was on the ground. I can see it here. It's on the ground in my normal elevation, so it'll be on the ground in my other elevation. So it's the XY line. Here is 8. Height of 7, again, I can copy it from this elevation. That's the height of 7 from the XY line. And when I come out, here is the height of 7. And what that gives me, and because it was horizontal, I can draw parallel to this XY line here. What that's giving me, these should form a perfectly straight line. So what it's showing me is I've got my narrow surface here on the left hand side. Here it is. My surface S is the true shape, so I see what the surface S actually looks like. So now when I draw it in, here is surface S. That's what it really looks like. And then I've got my front here. This is the front of the object, and the front now looks a bit squashed up because I'm looking in at an angle. And that is my auxiliary elevation completely finished.